All right, so now here we have a multi exchange reaction, or what we would call a double displacement, because we have Ki plus Pb with a polyatomic anion. Remember, NO3, it has that twice. And then we have KNO3 on the product side plus PbI2. And K went with NO3 and the Pb went with the I. So that's called a double exchange reaction because both components of the compound switched partners and rearranged to go with the alternate atom. Okay. Now the first thing we're going to do is balance the equation. So let's start with the one that is the most evident. Here we have on this side two iodine atoms, right? So therefore we need to put a 2 in front of Ki on this side. Now when I did that, I caused 2K, okay? Whereas at first I only had 1K, so I will also have to put 2K in front of the KNO3. Are we good so far? Now, the K's are balanced, check. The I's are balanced, check. But we also still have the Pb and the NO3. So on this side I have 1 Pb, and I also have 1 Pb here, right? That's balanced. I also have NO3 twice, and look, because of the 2 here, this whole polyatomic atom of NO3, that polyatomic anion, it also has 2 in front of it, so we are perfectly balanced at this point. So to write the balanced equation again, it's going to be 2 Ki plus Pb NO3 2 yields mean the reaction goes forward and produces 2 KNO3 plus PbI2. Okay, now I'm going to put a box around all of the coefficients. Okay, this has 1, this has 2, and this has 1 as well. Okay, now let's see what the question is asking us. If I have 0.455 moles of Ki, how many grams? Now be careful because now we're asking for grams. How many grams of PbI2 will we produce? Okay, we are not asking for units in moles like we were before because we were just going mole to mole, which was a relative proportion. This time we're asking for grams. So therefore we know that we're going to have to change moles into grams, right? And we can do that because for every 1 mole, there is a certain amount of grams associated with it, okay? So the idea is that we want to use our mole ratio first to calculate the relative number of moles, okay? So the very first thing that we need to do is determine how many moles there are in this PbI2, okay? How many grams per mole, okay? So let's start. First, we're just going to use the mole to mole ratio. So we have for every 2 Ki, we have 1 PbI2. So we can already guess that in this case, we have less than 2. We have a fraction of that. So now we should have a much smaller number because we start out with 0.45. Wow, that's much less than what we normally start with, right? So let's set up our proportion. 0.455 moles of Ki over 1. Now, let's look at our mole ratio, step 3. Mole ratio tells us that we have 2 to 1, right? 2 Ki for every 1 PbI2. So if we set this up, and I'm going to use a darker marker so you can actually really see this. I'm going to calculate this ratio, or this mole ratio of 2 Ki to 1 PbI2. Again, we're going to put the 2 mole of Ki on the denominator so that these cancel. And we're going to put the 1 PbI2 in the numerator, such that moles of Ki cancel out here, moles of Ki cancel out here. So as we did before, you can tell that it's going to be half the amount of product representing the moles on this side because it's a 2-to-1 relationship. So that number will then become 0.2275 mole of what? What we were asked in the question, moles of PbI2. So you have to get the mole first before you get the grams per mole. That's a stepwise 2-step process. Now that I know that I have 0.2275, I'm going to save that, but I'm going to erase this part so that we can see clearly the next step. Remembering that we were asked how many moles, right? How many moles? Okay, we were asked how many grams. How many grams? Now our new question is in 0.2275 moles, now that we found this, okay? Now that we found this, we're at the convert mole to the desired unit. So first we have to figure out how many grams. So let's look at our molecule, PbI2. Notice I am not taking the coefficient in front into account. Even if it was 2, 4, I'm not going to take the coefficient for my molar mass. I'm going to calculate molar mass, okay? That means how many masses is in 1 mole of each of these components. So I found that lead, or Pb, 1 mole of it is 207.2 grams, okay? And then for iodine, I find that there is a 126.9 grams. But look, be careful, there are 2. Remember, I2 means that the I and the I are both bonded together along with the Pb, right? So we're going to multiply that by 2. So when I multiply this by 2, I get 253.8 grams, right, per mole. And then this same thing, plus we add that to the 207.2 grams per mole to get a total molecular gram per mole of 461 grams per mole. But you may say, Ms. Kelly, but they didn't ask us for grams in a mole. They asked us for the answer in grams. So you realize that we can convert grams per mole into mole using the number of moles that we calculated. So here we start with 0.2275 moles that we calculated in the first part of our process, and that's over 1. And what is this moles of? This is moles of PbI2. Now, we have 461 grams per mole. So what should we do? We should set up our dimensional analysis, and we will put the grams at the top because we want to end up with grams, right? 461 grams of PbI2 over 1 1 mole, right? Mole of what? Mole of PbI2, right? So what cancels out? The moles cancel out, leaving us with grams. So all I have to do now is take the 0.2275, multiply it by 461, and the answer that I get should be, if you round it up, should be 254, okay? When you do the calculation. So did we answer the question? Yes. Because the question did not ask us how many moles, it asked us how many grams. So our final answer is 253.8 grams. Oops, that's not right. Oh, here it is. Okay, actually, our final answer is 461 grams, which is the total that we calculated, all right? Grams per mole, remember? And we multiply that times 0.2275 moles over 1. So the value that we get there is 105 grams. That's it. So that's, sorry, I forgot that we were supposed to do this part, okay? So we take the 461, the 275, or the 253.8, that was the amount of just mass due to the iodine, so be careful. So you take 461 grams, you multiply that by 0.2275 moles, okay? The moles cancel out. Then you get 461 times 0.225, which gives you 105. If you round it up, 105 grams, okay? Later on, you're gonna do a simulation where you're going to actually balance the equation in a simulation. It's gonna be a part of your exit ticket, and you will then be able to put the number directly in and see if you're right. You will record that into your exit ticket and then see what you get. But first, we have to practice. There's 3 more problems for you to practice. I'm sorry, 2 more problems, but if you're in honors class, you're gonna do problems 1 and 2. And if you're gen ed, you're gonna practice the problem 1, part A and B. Now, number 2 is very challenging because it asks you information in terms of density, but don't be confused, because even though they ask us the desired of units, we're trying to figure out the units. Remember, we can get mass from the density formula, remember? So that's just a little hint. All right, so if you have any questions or need help, make sure you reach out. I'm just a phone call away. I want to do one-to-one tutoring with you guys. Make sure you learn this stuff, because you're just gonna be way more prepared for physics and way more prepared for your other classes if you get this information in. Take care, we miss you guys, and I'll see you next week.